an electronic interface to the PLC that I would be using for all my demos and verification and so on. But that's not the interface that would be used to test your program. I'll show that later on. Okay, now what this box contains is a bunch of switches here, right here. So I can keep flicking. See, two lights have come up here. That tells me that input is on, and I can simulate up to 8 plus 2, 10 inputs. Okay, if I want. Not that I'm going to use it. So now you also see a little blue light come here. This is the input box. This is the output side. So if I can strike a logic, or this plus this and this, or this, whatever, and if I flick the switches here, I should see the output that I want it to be set. Okay, so right now I want to disconnect or turn everything off. Okay, so this image will disappear once I start moving into the presentation. So how many are there? 2, 4, 6, 8, 10. So people are still not there. Okay, let me share the first, maybe I'm going to do the housekeeping right away. Okay, do you see a Word document on the screen?
Yeah.
Okay. So, since starting, according to the schedule that the university has posted very recently, and what I got from the Faculty of Engineering Dean's office, there are 10 lectures and 5 labs for each section, which is normal. So 10 lectures, each week is 2 lectures and 1 lab for each BO1 and BO2. So there should be altogether 10 lectures, which is 5 weeks from the starting point. So I started on the 7th December, it's done. Now today is the 9th December, will be done. Then we have 4 more remaining. The university says classes will be held up until 24th December, but 24th is a Friday. So 23rd will be my last lecture before the Christmas break. So university's memo says no classes from December 24th, 2021 to January 4th, 2022. Or 5th, I'm not sure. But my lecture will start on the 6th January, which is a Thursday. If they had started on the 4th, I could have got one more, but I go by what they say. Then 6th, 11th, 13th, and 18th. Session ends on 19th January. Okay. So 19th is, I guess, a Wednesday. And then they say all exams will be scheduled not for the regular term courses, the courses that were not held during the sort of the interruption. Between the 19th or 18th, I'm not sure what they are going to tell me. Keeps wobbling back and forth. To the 21st. And then the winter term starts, I think, on January 20th. So, as far as I am concerned, I would complete everything. You will get everything that was posted in the course outline, except some dates are now changing. Okay. So the midterm test number 2, the date is gone. Okay. University's regulation now is for 72 hours. I cannot do any tests since starting, and I cannot ask for final submission of project reports, which I am not asking. I'm only asking for your Mastercam files. Okay? Because if you let go now, it's going to be hard for us to do any evaluation, a cut, or whatever, because it's going to take 45 minutes depending on how long your program is. So for 13 people, I'm looking at close to 10 hours. Okay? And it can be done in one shot. What I would do, I have put the revised date for majority of submissions, with the exception of a few who are asking for a little extra time because of time sync course, which is the capstone design. So I have 4 or 5, I'm not sure, in hand, which I will start evaluating. I'll do some preliminary evaluation on it, and then I don't see any major calamities. I would like you to come to the lab when we do final cut. We can do this next week. Okay, not all in one shot. I have to let you know based on your availability. So if you can send me an email for the next week, starting from Monday to Friday, whether you have any 1 hour slot somewhere. And if so, give me the date and the time. Then I will keep that in mind to schedule your cutting. Okay. But once it is cut, it's done. Then you can go and write the report. But when I give you the time, bring the caliper and the part, the original part. Okay. Is that clear? Because I have one more issue. The issue is the 11th January, Tuesday. I highlighted 8th lecture. After waiting for nearly 8 months or 9 months now, I do have a pre-operation appointment on my eye. I'm not going to be, there is no surgery involved on that day. But the guy wants me in downtown, not downtown, Health Science Center at 8:45 a.m. If I cancel, I may be looking at another 6 months of wait. Who knows? I have no clue. Okay, so I hate to cancel this appointment. I'm asking. I may be okay. I'm going to keep evaluating where I am in terms of lectures. I may either cancel that lecture, you can use it for your project, or if there is this is during the January time, if people have 1 hour and 20 minutes in the evening, like starting at 6 o'clock or 5 o'clock or whatever, I can finish that lecture. Again, I'm going to ask for an email response. Now, comes to the midterm test and the final. The midterm test is worth 10. The final is worth 40, as announced in the possible dates for midterm test are 22nd December at 7 p.m. or 12th January at 7 p.m. Okay. Another alternative, which I discussed with the associate dean and the head yesterday, I can roll your midterm final into one final exam worth 50%. Okay, so there are 3 alternatives for the midterm plus final. The date for the final is controlled by the student records. I don't think they have come to that stage yet at all. They are dealing with what's happening, right? And you will get to know when it is. Aurora, I assume. Okay. Any question about this? No decision yet, but this is how the course is going to be finished. With nothing compromised. Okay. So, can I ask for a feedback on the midterm test plus final? Do you guys want to roll it together, or do you want to keep it separately?
I prefer to all together.
All together. Who would be that? James.
James, yes.
Okay. Who else wants to? Maybe I should note down as I go along. Pencil, paper, whatever.
I would also prefer together.
I would also rather it be together.
1 second, give me a pencil. Rather, you're not going to give me a pencil. I have to find a pencil. Okay, starting with James, I guess. Spoke first.
Yes, together, please.
Okay, after that, is it Ryan?
Yeah, together.
Okay, number 3. How about Alan? No, James already said that. Okay, who else is there? Janice? Okay, I heard.
Can you hear me?
You're Janice?
Yeah.
Yes, I can hear you.
Together is fine with me.
Okay, number 4. Who wants to go? So I have 3 here. There are more people in the class.
It's fine with me as well.
Okay, Yusuf, Maria. Okay.
Yes, together for me as well.
You would be
Wesley.
Wesley. Okay. That's 6. There are 10 people registered on the WebEx. So there must be 5 more who haven't spoken yet.
Yeah, I'm
I'll be
unavailable.
preferring.
One at a time?
Yeah, I'll go first. I'm unavailable on the 22nd, so either the second or the third option for me. That's Omar.
Omar. Okay, so you said right now 5 people have said roll the final and the midterm. Are you going for it?
Yeah, that's fine.
Okay. Number 7. Somebody spoke along with Omar.
I'm fine with combining it too.
You would be Olga?
No, I'm Maria. That was Olga, the last one.
Oh, last one was Olga? I
Yeah.
didn't see. Okay. So, 8.
I'm fine to do it together.
And you would be Kwang?
Yes.
Okay. Number 9. Okay, you would be Long Pan. Okay. And 10.
I'll be preferring combining together, please.
Which one would be Tan? Tan Bui. Okay, is there anybody else? I started with 10. Is it 13 now? There should be 13. 11, 12, 13. So 3. Did anybody get not to speak so far? Okay. So I am going to read out because I'm going to send email to the last 3. James, Ryan, number 3, I didn't mark a name. We will come back to you. Maria, Wesley, Omer, Olga, Wang, Longpan, and Bui. So whom did I miss? I missed somebody, number 3. I'll read again. James, Ryan, Maria, Wesley, Omer, Olga, Wang, Longpan, Tan Bui. Is it Tan Wu? that I missed?
Yeah, I haven't spoken yet.
You
So
would
if
be.
the major,
You're
if the
Tanwu?
major, yeah, it's me. Yeah.
Okay.
I think I'll follow the majority of the class, so it doesn't
Okay.
matter to me.
So it is Tanwu who is speaking, right?
Yes.
Okay. So I have 10. I'm not going to go to the participant list and see whether the 3 who are missing here or not. I'm not sure. Okay. I don't want to waste my time. So it seems to me out of the 10 who are likely present, all 10 would not mind moving the term final together. So I'm going to let the dean's office know, as well as the department who are responsible for scheduling this. When they come up with the date, I'll let you know. Okay, that's about this. I have also received 1 or 2 emails about being away beyond January 5th, I guess. This is what I would like to suggest to you. My lectures are online. So if you have access to your Wi-Fi or whatever, you can even listen to my lecture on your cell. Okay. So from what I have seen, it is likely people may miss 1 or maximum 2. And one of them is the 11th January, which may be cancelled. I'm not sure. I'm looking at the alternative. I'm going to call the doctor's office today and see whether they will bless me with a different date. Guy is very, very busy person. He probably is not going to alternate. I have cataract on both eyes, and I have a very compromised vision right now. So it must be done. Can't pluck my own eye. At the mercy of those people. Okay, so what I am going to do is to show you PLC, go through the software. The people who are in Thursday group will see the problem definition of project number 3 this afternoon. But the PLC software, I will go through right now so that during the break, you have access to it.
I have a quick question, Bob.
Yeah.
Is there any chance you can record the lectures?
I don't know what's involved, and I don't have a good setup here. It can happen only for classes after the January session, not after the January, not before the break, because I'm basically putting together all the stuff that I have to use for the lab. I can try during the break to record.
Okay.
Okay, I'm going to close this screen and move on. Share. Didn't. This way. Okay, do you see a different screen now?
Yeah, we do.
Okay, so should move. Okay, what you see on the screen is the PLC. On the right hand side marked 240 watts output. 3 inches by 5 inches by 6 inches is a power supply. It's a 24 volts. When it says 240 watts. You expect it to be 10 amps at least. No, at the top it says input 50, 60 hertz, as well as 100 or 240 and 3.5 amps. That's the input current. So I can tell you that this power supply can handle up to 10 amps. This PLC and many other PLCs work with the power supply that requires plus 24 with respect to your ground. Okay? And then there is also a shield. This power supply alone would cost you about $300. So can I use a battery? The answer is yes. If you can combine two car batteries and produce 24 volts, you know what the weight would be. This one doesn't weigh that much. It's like a power supply. So if you want to save $200, you probably are better off in buying this power supply because it can supply many other PLCs too. It comes separate. You got to wire everything together. Okay. Now, what you see on the left-hand side of this power supply is the PLC, the processor, which is the leftmost block, followed by 1, 2, 3, 4 additional modules, which are going to expand the capacity of this PLC. The base unit with the microprocessor will give you 8 inputs and 8 outputs. The projects you're doing will not exceed 8 in and 8 out. So it is sufficient. This is the PLC that's controlling my robot cell. Okay. Then you can expand by banks of 16 inputs or 16 outputs. You got to buy those modules separately and piggyback the master or mother unit. So in this case, it's got 32 ins and 32 outs in addition to the base 8 plus 8. Okay, so you see how I can expand. Actually, my cell needs more. Okay. So you can go up to 128 inputs and 128 outputs on this kind of PLC, the PLC that I have on the picture. There are other PLCs which will expand it more. Okay. Orders of power. Okay. All those wirings are all done by me. So nothing is coming as commercial because these wires go to different sensors and whatever. That's how the interface starts coming in picture. So this PLC is made by the company called IDEC, and the name of this PLC is MicroSmart Pentra. That's the processor. The modules that you're attaching, they will not go with this name. They are some numbers that they will tell you. IDEC, there are 4-digit numbers. Okay, so IDEC MicroSmart Pentra PLC. This is not the first PLC that I have used. I have gone through several generations, evolutions of PLC, starting with Sysmac, then going to Allen Bradley, then going to Omron, then going to GE, and for the last, I would say, 8 years, I'm staying with these people. These are the last to come, as far as I know, in the market. Okay, there are more that have come now. Why did I choose this or something else? I was with Omron for a long time. Omron is a Japanese machine. Omron in the North American market, Allen Bradley dominates because of market control. They are the ones that have readily passed through the safety standards of North American industries. So they have now monopolized their market. Because if you want to implement PLC or anything now industry, the safety board, some rep will come, will have to certify out whether it's built the way meeting all the electrical standards and codes. Right? So you can't just put a PLC together. I don't do any of those in my lab. No, I don't go to any safety standards. I'm the safety inspector. Twice or thrice the university physical plants who always are looking for work said I have pinch points in my robots, I have this and that. I told them way out is through the door. So they never bothered me after that. So there is one more picture, guess. Now this is the side view where you can see blocks attached together. The first one is your processor, one big block. The next one is an input module. The one after that is an output module, then an input module, then an output module, and I can keep adding up to 4 more stacks. Okay, and the power supply sits in the end, powering all this. Power is required to supply this PLC. I mean, to make this PLC work. Okay, that's a close-up view of the side view. It's got IDEC everywhere. Okay, and TB1 stands for terminal block. Okay, so wiring everything is in my head. What you would be using is this same PLC, but with only the first 8 and 8 in. Okay, so that's about this. So I can get back to this picture. Share. Where am I going next? I've done this. So I am going okay. Do you see this screen? I've been a ladder logic diagram.
Yeah.
Okay, I'm in business. Okay, I'm going to delete all of this and start all over again, or I'm going to say file new. Okay, so what you would see, your detail manual is there in D2L, but I am not going to refer to the manual, so I may go a little. I'm going to say, okay, there is an icon at the bottom that stands for the WinLoader. That's the software that you're going to be using. It's it will operate under Microsoft Word, sorry, Windows 10 and downwards. I'm operating on Windows 10. This is the software that is present in the common pool for you. So click on WinLoader and the screen will open up. It'll go through a few dances. Say simply close because it would want to update. If you don't say close, it might go and look for an update. But with its wherever it is sitting, we can't update anything onto the structure the way it is. I can do it in my lab. So it'll open up with the screen like this. Okay. Pull down menu will take you all over the place. First thing you want to check is to click on configuration. This is very important. because the same software works with a number of different PLCs made by IDEC. This software is only for IDEC. Everybody has their own versions of software, okay? And there will be differences. Now, how was the PLC programmed before these softwares were introduced? Software has been there only for the last 15 years. Before that, you will have the PLC and you have to hook up another interface which is called the teach pendant, which will have a tiny little screen and will have a few buttons, and you say this input and then say and then say another input and then say not or whatever. Those are available on the keypad. You have to keystroke one by one and store it to the PLCs. That's how some of your very seniors did their assignments in the lab. Now, with this software, which is not a freebie, you got to pay for it, but it's one time, something like 1100. But again, let me not quote what it is today, because 2 years ago, before the pandemic, during the CIMA 2 course, 2 PLCs got destroyed. Okay? Literally went up on flames due to some not following what was told. So the PLC's processor, we have been buying at $220 US. So about a month ago, I told Dave, maybe it is time we get 2 more restock. So he went to the California company and they said, we'll send you a quote. The 220 became $1,184 US, almost 4 times. The explanation given is that it's not being produced as much because of COVID, and we have very limited stock, and this is the price. Well, Dave, don't buy. Let's move on. COVID is hopefully going to clear. So this is how some business make use of what's out there and what's not out there. So if you want to buy a PLC with a 8 in, 8 out on the power supply, you're looking at $800. Plus, if you negotiate, they may give you the software free. I have not paid for the software, except they've allowed me the license to run multiples. Okay, so let me go back. Configuration. Hit on configuration, you will get this pull down menu. Click on the PLC type. It's very important. Okay, it's in the my manual. FC5AD16RX1 should appear. I have put it as a default, so you may not have to change, but sometimes it moves one above to the 24, if I can read the screen, right? If you set 24 and accept it and write the ladder logic program, when you want to actually download to the PLC, it's going to come back and not warn you. You will say incompatible PLC, that your program was written for something else, but easy to fix. You can go back and put the 16 back and let it recompile. Not a big loss, but be aware. This is written in my manual. Before you start, you have to set this up. Okay, so it's done. Oh, moving down. Okay, now I'm ready with the blank screen. I am going to now construct a ladder. I go to the home. I have a ladder in front of me, the piece of paper that I want to use. Okay, I am not going to follow. They're too small a print for me to read right now. So I'm going to go to basic. I'm going to hit the normally open. And on this box, I'm going to go and click. See, the contact normally open has appeared as a symbol set. What else do I want to do? I want to go here and add another, not online, sorry. Add another input, this time normally closed. I'm going to click here. Okay. So now I got two inputs. I don't know what they are. One input and the other input not true. And I want to generate an output. Okay. So I'm going back here, basic, and I'm going to say out. Normally, not normally, output. So I got a ladder here. One ladder of multiples that I'm going to construct. Okay. Now it is meaningless because we don't know what these inputs, is it input 1, is it input 2, is it input 5, who knows. So you have to assign an address. So I go here and click on this, double click. This little screen in the center pops up. Okay, so there are 3 dots here. It says normally open. That's what I said. Look at this. I followed by 4 zeros. 0, 0, 1, 2, 3, 4, 5, 6, 7. It stops at 7. So 0 to 7 is the first 8 inputs you can use. Then if you add additional modules, it doesn't start as 8, 9, 10. It starts at 30. 30, 31, 32, 33, 34, 35, all the way to another 8. Then it'll jump to 40 to 47. Then 50 to 57. 60 to 67. Why this kind of a numbering system? Well, these are all digital. It is a binary representation inside. So don't question, right? So I'm going to choose the first input, I0, close. I can add comments here. Okay, I can say input 0. Don't make it long, because for whatever reason, we're going to see. See, at the top of that first box, I followed by 4 zeros with the input 1 appeared. This input 1, I could have said power or fan or whatever that I'm going to call that variable as. Same way, now assign something else to this. I'm going to choose. This time I'm going to see I001. Okay. And I'm going to call it as input 1, but it's a duplicate name. Okay. So this automatically changes to 0 and 1. And nothing in between. I'm going to go to this. Now, watch what's going to happen. The default is input. You should change it to output. This I would say software is not that smart. When I chose a symbol set which is an output, it should automatically take me to the output assignment. It doesn't. Okay, they will fix it at some point. So the first one is Q followed by 4 zeros. I'm going to choose that. The difference between the input and the output is the first letter I or a Q. Okay, you don't have to do it. It'll automatically assign. So I'm going to put a comment, output 0. Okay, done. Okay, I've constructed one ladder. Right? Now I have a number of ways of doing this. I am going to go append somewhere here. Append a ladder line or a rung. I'm going to append a rung. Okay. So what happened is it automatically is now going to create the first ladder step with the one rung. Move to the next step, and there is one here that can be deleted home. Somewhere here there is a delete command. Delete ladder line. Okay, now it looks clean. So what am I going to do with the second rung? I'm going to do something else. Okay, go home. Basic. Let me use the same stuff. necessarily one of them. Then what I'm going to do is append a ladder line this time. Okay, so it opened up. Now I'm going to put another input here. Let me put normally. Okay. Now watch what happens. I'm going to join these two by line a vertical line. So what is this operation in comparison to the previous one? It is an OR at this point. So what I'm going to do, you can do multiple ORs and so on by joining lines. Then you can also do this. I'm going to draw a horizontal line. Then I can put another R here, but right now I'm not going to do it. I'm going to simply say I want an output. Okay, and this output is going to be something different. That's an important point. Should tell you very soon. So I'm going to call this as 1. Output. I'm not going to bother labeling all this. Okay. So I got it here, but I have not assigned anything to the input. So I go back here and assign an input. 1, close. Okay, see, it keeps the label that I already created. And I'm going to this time say something else. 3, or 2, sorry. I'm going to select 2. Done. Okay, so another one is done. Okay. Okay, let me stop here and close this program. So I have 2 choices. I can create another rung at this point, or I can embed another line underneath. When you have a program, you must tell it this is the end. Otherwise, PLC is not going to recognize it as an end program. So go back to basic, program flow. There are all kinds of stuff inside. I chose the end. Now, this is a very, very compact, small program that I have. Not a big deal. Basically, I showed you how to construct, transfer your equation. So, the equation would have been input 0 and not input 1, set output 0. That would have been your equation for this. Then maybe another second output, something else. First one could have been a fan, the second one could have been a heater. Input 1 or input 2, set output 1. That's it. That was your equation, and that equation now got transferred into the screen as ladder logic. This is the stuff that every PLC understands, but not in the symbol form. It has to be converted in what's called as a mnemonic code, which is high level, a low level language. That means you're going into the assembler kind of language to make it very fast. Okay, so how good is it? Well, store it first, whatever. Just save as. I'm not going to do that. You can. Okay, let's see. Save as. The default is project 2. It will go to your default directory. You can direct it wherever you want. I call it as junk 1. Okay, done. It's saved. How do I know this program works? And when you are developing your program, you're not going to have link with the PLC. So how do I know this code is right? You can simulate on the screen, which is what I'm going to do now. So go online, then simulation, work simulation. So it shows a green against 0001. Okay, so that statement is true. Since input 1, it says is not closed. Okay, everything else is open, so it doesn't show the green. So I want to simulate this first input 1 at 1, 0 to be true. Go and click on it, double click. It became green. Is the rung true? Yes. Input 1, I made it to be true. The input 0 and then input 1, I didn't do anything. Default is normally closed, so it is true. Output 0 was generated on the screen. Okay. Now I am going to go and click on input 1. Boom. This disappeared. This output disappeared because I made input 1 to be true. As a result, Q0001 came on. Now I'm going to go and click this. Output still remains the same. I'm going to go and click this off. It remains the same because either this or this needs to be true. I go and click on this. Output 1 collapsed. Okay, so you can actually simulate on the screen before going to the PLC. This is why I said I'm pushing today to show you the software. During the break, once you have got all your equations kind of ready, or I'll tell you what you should do. You can keep checking whether up to this point does it work. Few cautions in any PLC. Like for example, here I0 and not I1 generates output 0. Right? Then I want to say input 1 or input 2 should also generate Q0. Absolutely no in PLC. You cannot have multiple ladder or rung generate the same output in different places. It confuses the PLC. So if you want two different conditions to generate the same output, you have got to do an OR operation. That means you draw line between this and delete everything else. That means you have the first rung or the second rung generating the same output. Key, which many people make a mistake at the starting point. Okay? So keep that in mind. So let's close this simulation. It's gone. Now what I am going to do online, download, upload. I've already structured what PLC it is. My PLC is now hooked up through my USB. Okay, so, and it's also configured. Now you have to go to configuration. This you may not have to do because Matt or myself will be checking on this. Configuration, PLC type, before, okay, then, okay, now online, go to download. I want this, whatever I've created, to go to my PLC. It comes up with the screen. Okay, I can go and look at the communication settings. Windows 10, 8, whatever. They have got some excessive amount of communication port settings inside, like your graphic interface, your screen, your keyboard, They're all going through. So this software has to know which communication port is connected to this PLC. Okay, so if you do not know, get this automatic detection, which you don't have to do. We will do it for you. So automatic detection for communication, it established that it is already connected because I did this morning. So no problem. If this says no, I can't find your USB port, you can't download the program until you really configure it. So I'm going to now download. The program is going, whether it's 2 lines or multiple lines. USB port come off. Okay, something is not right. The type 15, yes. Expansion, they're all right. Simulation is not there. Good. Download monitor, yes. Okay, it's going now. There's always glitches in digital technology, and you have to try more than once. Okay, it's done. Now, instead of green, you're going to see red buttons. I'm going to use my interface box to simulate the sensors. Is input 0 on? Yes, it is on now. I see the lights on my box, but you are seeing it on the screen. Okay, so I can simulate now. I don't have to go and click. I'm using the PLC to do the job. Okay, so gone. Now input 0, output is not coming. Output is coming. You can hear the noise. And then 3. Okay, output 1 came on. So this is, instead of simulating with the hand, we are going to use the interface box, which has got also the switch to represent the different things in the first project number 3, like the furnace fan and so on, marked. And when you're ready, going to interact with us. We will show you what happens in that box, and if process behaves exactly the way it should be, you are done. This is the first time I'm using these interfaces because I built them during summer, because I knew online SEMA 1 is going to be online. So I can't use the modules, I can't bring them home. There are physical models in the lab to actually see what happens. They're all big and I can't bring them. Okay, so that's the first program. Now I am going to create something else to expose you to other options. What I'm going to do, tap this online, monitor. Now the program is back. What I'm going to do is to change this output. Okay, I'm clicking on that output. I'm going to change it. Change it to what? I can put another output, but I'm going to demonstrate to you other options available in the PLC. I'm going to go and click not as an input. Look here, internal relay. Okay, so it came up with a prefix of M, not Q. So I'm going to choose M00. Those. I'm going to type INT 0. Internal relay 0. Okay. Don't type too long sentences, it'll become cluttered on top of the screen. So abbreviate. So I changed this to not a hard output, but an internal relay, which is a software register inside the PLC. The difference between the internal and an external output, the internal sets a flag inside the PLC, which can be used as a variable again elsewhere in the program. Okay? The Q, hard output, is actually going to the terminal of the PLC to light LED in my case, or turn on a fan, or turn on a heater, or whatever. Internal will not do that. Internal will stay as internal. Now, what I'm going to do is to delete this line, okay, and to erase this line that I have drawn. Oh, there is an eraser here. Okay, I got to go and wipe this off. Done. Okay. Now what I'm going to do, I'm going to change this input 1 to an internal relay as an input, M. Okay. And I'm going to choose the one that I created on the previous line as an input. So what has happened now? Output on the first rung has become an input on the second rung, and an output, hard output, is going to be generated. Does this work? Okay, let's go to the simulation. I'm going to take this off. So input 0 is off, input 1 is off, but it is a not operation, so it shows as a true. So I'm going to go and click on this. The internal relay became true, and the internal relay as the output normally now has come back as an input and is setting a hard output Q. Absolutely possible, no issue. Now, how many input? I told you about how many inputs you can have, orders. How many outputs? You don't have to pay for them. It is inside the module. You can have 99 internal relays, 999 relays. Obviously, with this having 4 zeros, it has got 999 internal relays. They are not relays in true electrical sense. They are software registers. Okay? So, I familiarized you with one more. Now I am going to click on this, and what am I going to do? Delete all this. Now I am not following my manual. It's going to create it. I want to show you 2 more things. Let's see. I have the manual in front of me here, but I'm not going to refer to it. Okay, that's what I have. So, home, basic, normally open, click here. What I am going to do now is different. Home, basic, I'm going to go to a timer right here. And I'm going to choose a 1 second timer. I can choose a 100 millisecond timer, okay, 10 millisecond timer, 1 millisecond timer, and so on. There are all kinds of options. I'm going to choose this, okay, and I'm going to click on this box. So it puts TML, which stands for timer, okay. Then I'm going to go here and say output. Okay, so I've constructed a little diagram here, and I am going to say that's the end. Basic. Oh, I'm going to delete this. And this is not needed. Or to delete. Wrong. It's duplicated, so wrong. Gone. Now I have to assign addresses. I'm going to say input 0. Back again, same. Because it's a different program now. Watch this. I'm going to, okay, let me finish this. I'm going to complete this output, which is already, I have already gone through this previous example. So, yes. Now, what should I do with this timer? Click on it. It opens up with a different dialog box. On the left-hand side, it says TML, 1 second timer, because that's what I chose. I can change it at this stage. I have to give it an address. So I click on this. I have to choose timer. Okay. I'm going to choose the very first one that appears there. And I'm going to give it a interval. I'm going to store a value of 5 seconds. Okay, done. So I explained to you in the lecture how the timer works. That's the assumption here. So online simulation. Oh. Okay, so input is off. What is the value that appears as red in the timer? 5. Stored value in black is 5. Output has not been generated. So I'm going to go and simulate. Okay, look at the timer. It's counting down. 5, 4, 3, 2, 1. When it becomes 0, the output is lit. Condition, this input must remain true. So I'm going to change this input to not true. Timer has reset. Output has collapsed. Very simple one-line demonstration of a timer. You can put all kinds of other conditions to trigger the timer. You can say if input 0 and now not in 1 and 3, then put an OR operation, whatever, and then join them all together and then initiate a timer. And then the timer can be initiating a internal output or an external output. All kinds of possibilities exist. Okay, so now you know whatever I said in the lecture. The timer can be reconfigured in a different way, but for your furnace exam assignment, use this as the mode. Now I'm going to demonstrate to you what I'm going to demonstrate. A counter. Okay, what should I do? All new. I want to save this. Okay, so home, basic, normally like we open. Okay. I'm not putting any address to it right now. Here I am going to say, watch me, basic. We did normally open, normally closed as input and output and an output, and now I am going to go straight counter. I'm going to take the adding counter. I'm going to click here. See, automatically it put an extra line with the top line marked as R, which is reset, and the bottom line marked as P. In some PLCs, it's the opposite. You have to know what is the configuration of the PLC. The bottom is the trigger line. Okay, so I am going to go here and I'm going to put another input. Normally open. So the top one, I'm going to give it an address. 0, my usual choice. Close. Okay. This one I am gonna choose something else. Change I7. Then I am going to come back to this counter. Okay, let's finish the counter. Like the timer, it's asking for an address. So choose the counter. First one. And I have to put a value. Let me put a value of 3. You can put anything you want. Now what I'm going to do is an output. Is it? Choose not this. I'm going to choose this output, which is called set. I introduced this in the class. Set. So there is a letter S appears. Okay. Now what I'm going to do, append a line. I will add an append wrong. Okay. Now what I'm going to do, home, input, normally open. I'm going to say output. I use the set. Now I'm going to use a reset. Okay. So let's do this. I have assigned this, and I'm going to assign an input to this, and I'm going to call it as 3 or whatever, a different input. Okay. Now everything in this block is all done. I got to choose an address for this. It's a set output. Let's take the first one. Okay. Now you're setting an output and you're resetting the same output. So it has to be same, whatever that you chose as S, as set. Now I am going to say put 0. So you see here, set is Q0, reset is also Q0. So what happens? I have to close this program. Program flow. Okay, program is done. Simulate. Online simulation. I am going to close this. Counter has got a value of 3. So this top line is the reset line. Right now it is on. I'm going to go and hit the trigger line. Has anything happened? Because this is locking it. So I'm going to reset this. I'm going to release the reset. That means it will allow the counter to do its job. Okay. Now I'm going to hit on the 7 once. And it's on continuously. Counter is not going down. It went down by 1. It has to come down. The rising edge is what's triggering the counter. So counter value has now become 2 in red. I'm going to do this. Now I'm going to go and click this. Boom. Counter went back to 0. I'm going to repeat. So the reset line has to be low in order to the counter's trigger to work. 1, 2, 3. Counter became true. The set line has set the output to true. But you also see the green on Q0 on the reset. This is a little software, their issue. They should have left it as no green. And they should have made it into a red when it comes into play. Okay, so now I'm going to reset this counter. Okay. Now this is set. It did not go down, even though counter has been reset. Why? Because it's not a standard output, it is a set output. How can I turn this down? Well, go and hit the reset on the other one, it goes. So I've introduced you on this ladder, use of a counter to trigger an output, and I didn't use a standard output, I used a set reset out, which I have covered in the lecture classes. Okay? Now you are seeing it actually. Okay? So that's the what I have introduced you to is standard inputs, multiple inputs, output, single, multiple, timer, and a counter. These are your basic building blocks required to complete your project number 3. Don't need anything more, even though there are more functions available. This is it. This will do the job. Okay? So if you ask me in the furnace control, how many rungs should it be there? So not to be confused and not to, I won't be by those assertions. When I say you must make a compact program, people say, well, I have only one rung. But within that rung 1's content, rung 2's content, rung 3's content, rung 4 content, rung 5 content. So one big program with no break. Okay, one rung, but it's got multiple steps, right? Another person with more discipline comes up with rung 1, rung 2, rung 1 does this output, rung 2 does the another output, rung 3 does more discipline. You can comment the rungs also. What has a lesser number of steps? Again, not to be confused. Within the rung, whether you have a lot of nesting, it's ultimately the file size. Is it 14 MB, 7 MB, 10 MB, or 50 MB? You can easily look at the properties and check whether the program has taken more space. Okay? So the furnace program could be, well, it varies. Some people do it in 6 rungs or 5 rungs. Some go 17, who knows. So more elegant programs will have to be compact. Okay. Any questions? So the manual for the software is already in D2L. My advice to you is don't go into the software first. You don't need it at this point. For project number 3, I've already explained what you should do before going to the software. So do that first, then go to the software. Because once you click into the software, it's a question of after you complete the software, which could be maximum half an hour or even less. Testing is 3 minutes, 4 minutes. That's it. And if it doesn't work, you are going back to the drawing board. Usually people have gone 2, 3, 4, 5, 6 times, 7 times, who knows. I have never seen anybody get it on the first stroke. Any questions? No? Okay, this is what's going to happen. I'm going to send each one of you an email or block email with regards to this, how the course is going to be delivered. I counted, we have 10 lectures totally. So I'm finishing the second lecture. So if you want to count that way, I finished 20% of lectures out of the 10 that needs to be done. Tracking it, because I want to make sure that I cover everything. The labs is a different story. This afternoon, the Thursday group will, well, I'm going to present the project There are two choices. One, you come to the lab and listen to me in the lab, make the presentation. Or one of you want to come to the lab, so I have to go to the lab and present it from the lab through WebEx. So stay at the end of this class. We should figure this out. Either I go to the university and deliver this afternoon's lab, or deliver the presentation from my house is something I want to decide. Okay, that's it for me now. Just the Thursday group alone, please stay. Any questions? Nope.
Dr. Bala?
Yep.
I had to miss the last lab because I had a chemistry lab I needed to attend. I'm normally in the Tuesday group. Could I come with the Thursday group?
Okay, stay right now. Don't run away, because if you want to come, I got to invite you.
Okay.
You're not automatically, WebEx doesn't allow you to come in automatically on the Thursday presentation. I got to send an invite. I can do the invite only after I open the WebEx, which is 15 minutes before, at 2:15. Okay, if the other three guys in Thursday group say they would not mind coming to the lab, do you want to come to the lab?
Yes.
Okay, then stay. We will decide. Anybody else? No, then everybody except the Thursday group can go. I just want to talk to the Thursday group.